as well. So in this case, we have a square root of 5 in the denominator. In order for you to rationalize that denominator, I need to multiply the numerator and the denominator by that said radical. Because whatever I do in the denominator, I do in the numerator. Okay, let me zoom in a little bit. So let me show you why that's possible. So now, when we multiply radicals with radicals and whole numbers with whole numbers. But if you notice in the numerator, I can't basically combine them. It's not going to give me a square root of 10 because 2 is a whole number and square root of 5 is a radical. So it's like they can get close to each other. It's like they're dating, but they're not dating, you know? Like they're together, but not together. You know what I'm saying, right? So they're really close. In the denominator, though, this is a radical times a radical. So we can combine those through multiplication, which gives me the square root of 25. But the square root of 25, that's one of those perfect square roots. So that can be broken down. So the square root of 25 is 5. And I know there's going to be some people that's like, oh, it's plus minus 5. Pause. It's only plus minus when you're doing with solving. Okay, that's when you put the plus minus when you're doing that whole square root method to solve for x. We're not solving, we're just simplifying. Okay, so in my numerator, it's going to still be 2 square root of 5. And I know you're going to be tempted, you know, just like that nice piece of chocolate cake that you always want to eat, right? But you can't simplify this radical of 5 with that whole number of 5. They're two separate worlds, okay? They can hang around each other, but they can't